Hey folks, this is a towel warmer made by Zadro, as you can see there. Towels go in here and they warm up. It's plugged in, but stopped working. Dead. Plugged in, you're supposed to hold it and then it'll turn on and you can set the timer 15, 30, 45, 60 and then off. Now, there's something rattling around inside of here. If you shake it, I don't know if you can hear that. And so what exactly went on here? This is the information. And we're gonna open it up later and see maybe the element burned out or the fuse, but it doesn't give me a good impression if there's something rattling around. Something blew and is now loose inside of this this electronic device. In any case, let's find out what happened. But this thing was barely used. It only was used a few times in the last few years, and then it just decided to go one day. So not really sure if anyone else had this experience with this brand, but we'll see if we can repair it and what's wrong with it. Okay, so this is the Zadro towel warmer that we had a look at earlier. I ended up unscrewing all these Phillips heads here all the way around. Looks like there's, how many there are there? 10 maybe? And I got in. Okay, and it revealed absolutely nothing. As you can see, there's a tub of plastic here. There's a circuit board here. That's probably the power supply. Maybe something's fried on here, but I can't see anything from the inside here. Can't tell. There was something rattling in here, so we're gonna have to see what that might have been. And all the way around, there's nothing. Just a tie down for the plug there. Okay. It looks like we're gonna have to open this up a different way. I'm not sure what the next step is. I'm gonna have to analyze how to pull this up. I'm assuming that the tub and the insides somehow slide out. I can't seem to be able to separate these guys, but that would be the next step. Maybe I can split the halves apart because without this thing holding it down, I mean, even those screws just went straight down to here and it went into this case. So that might have been holding the two halves together on each end. So we'll see if we can get into this a little bit deeper. But yeah, nothing accessible really from this bottom end here. All right, I turned it around and it looks like there's an access hole right there, there, and there. So I'm assuming that underneath these, I can somehow pry those out, find another screw, and be able to pull the top off, and then that may release the tub. So yeah, let's see. There are some screws down the side here, as you can see. Those look like rivets. I think they're just holding the heating element up against the side of the tub. But yeah, it looks like we're gonna have to find a way to pull out these little caps here, and maybe in such a way that it doesn't reveal that it's been opened, because I'm sure it's gonna leave a mark. These are not rubber, they're like hard plastic, but it looks like you can maybe get in there carefully and pry it out. Okay folks, so I was correct. This little plug here, hard plastic, you can see I've damaged the corner there, getting the corner and trying to pry it out, but it hides another screw. So we're gonna have to pry these out all around. There's another one, and maybe I'll just hammer this down flat afterwards to fix that little tear. But we'll see what happens after all of these are removed on top. Okay, so I've managed to remove all 4 of the plugs. The first one had the most damage, and the second one, but the third and fourth are not too shabby. Should be easy to clean up. And now we have access to 4 screw holes. There's 1, 2, 3, and 4. And with that disassembled, we might be able to get to this control panel here on the front, right there. And as well as remove the tub inside and see what is rattling around in there. And see, try to listen if there's anything rattling still. Something's still rattling. So it might be inside the tub. You hear that? Oh, there it is. Huh. I think we found our culprit. You? Okay. I guess the power supply. It's interesting. I mean, I still needed to remove the whole thing because I can't see how I'm going to pull this board out without taking the tub out. But I think we have an answer, and it looks like this thing blew a cap. I've never seen a cap disassemble like this, but the whole top flew off. Usually they're supposed to blow by the score mark here and pop open, but this is just popped the entire cap off. Made by Hooray. Okay, 470 microfarad, 35 volt. Obviously, that probably had something to do with it. Hopefully, it didn't damage this thing too badly, but I have tons of these sitting around and they're cheap as dirt. So that should probably do the job and bring it back to life. So let's see what happens. Okay, everyone, so I managed to unscrew 4 of these screws here. And as you can see, the whole thing pulls out. It basically releases from the bottom. Now, the only problem is I have to somehow get this up and out of here. I'm not sure how to get this. I mean, I may not have to completely release it. Just get enough down so I can get to the board there. So that's enough of a release that I should be fine. I don't have to completely remove the whole thing. If I just leave it like that, I can access it. Okay, so you can see the board in here. Now this control thing here is taped down, so I don't want to start pulling the whole tub out. I got it propped up here so I have a little space. You can see how they mounted the board inside of these 2 plastic sort of sleeves. It's supposed to fit in there. This side is not fitting in there at all. You're supposed to be able to unscrew these 2 little screws and washers up top and slide the board out. But guess what? That doesn't really do much. You see, I was supposed to be a slot here and the board was supposed to sit in there. So that's the board there. I'm gonna have to pull this off of here and the 2 here so I can release this thing, and this should come out clean. But you can see the cap that blew right there. That's dried out, and all you see basically is a some kind of paper. And there's no electrolyte in here at all. You see? It's just a wound up piece of paper. So interesting. There's another cap there. 105C. I don't know. Not really confident about the quality of any of this stuff. But let me open this up. Just disconnect the board. Can I pull out this other cable? No, it's soldered on. Great. So how am I supposed to do this? Even if I pull those out, this one is soldered in. So it's going to still be hanging on to this cable here, which I'm not sure where it goes. So yeah, there's one more cable here that does not disconnect, at least not easily. So maybe I will have to find a way to pull this control board off. I don't know. That's really stupid. That is just a dumb way to do it, because I can't slide this out. All right, well, anyway, let's see how far we can get. All right, folks, so I managed to get the tub out. Apparently it was connected to the controller on this side and the power supply on that side. So as soon as you disconnect it from each side, the whole thing just slides out because it's no longer hanging on. So the cable used to go there, and it connected to the control board here, okay, into that slot. And we have some kind of temperature sense there, and the board is now easy to access, and I can just do whatever I need directly with this connected. I don't have to unconnect anything. And yeah, we're gonna eventually change this cap. This electrolytic cap dried out completely. I don't know what in the world is that bridging across it. That's interesting. They're like a Zener diode that's basically connected across the leads of this cap. Okay, haven't seen that, but there it is. And there's something, what did they do? Wax it down there so that it would stay. There's this brown reddish stuff there and there. So maybe it's, yeah, I'm gonna have to figure out how to put this thing back in the same configuration, but I have not seen that before. That little tiny Zener, what looks like a Zener diode across that capacitor, EC3, okay? But yeah, if I unsolder it, it should come off, and then I have to be careful just to make sure I put this thing back where I found it. Little surface mount there. Oh, and just for those of you who are not familiar, the cap used to have a lid on it like this. This was on top of it there. So it overheated and blew, but it failed at the bottom rather than breaking open at the top. But this is what failed. That's how it's supposed to look. High ray, some piece of garbage knockoff capacitor that doesn't last at all. No temperature rating on this thing even. Oh, there it is. -40 plus 105 C. I don't know. Whatever it is, didn't last. The one next to it seems to be hanging in there, but I'm going to test it as well. I'm sure it's not very good either. And there's not much else on this to go wrong. I mean, some transformers, and that's it. I don't know what other things we have here, but yeah, that's it there.
Okay, so I tried to reverse engineer this schematic for the board there, and this is what I came up with. Now, I'm not sure if it's exact. I might be wrong on a few things, but I'm not exactly sure how it works. But maybe someone who's watching the video can clarify. And I'll include some pictures of the board, some close-ups later. But basically, you have the line coming in here. You see where the mouse is. There is a fuse, and there's a cap, C8, that crosses over from line to neutral. There's also a relay that essentially crosses over and turns on. When it does turn on, it allows the full line voltage to go through the heating element and the thermal reset fuse, which is all part of the circuit that goes around the tub. And that relay, as you can see, is turned on and off by this DC component on the other side here. So the green is the AC part of the circuit, and I put red and black as my plus and minus parts of the DC circuit. There is a bridge rectifier at D4, which allows the line voltage to get rectified and become DC. That also goes through a couple of caps and SMD resistors. There's a large vertical mounted resistor as well, which probably reduces some of the voltage through the rectifier. Now, on the other side of the circuit, the cap that's blown at EC3 is part of this circuit. I'm not sure exactly how it works, but it seems to be connecting to Q3. I believe the controls on the top of the unit essentially allow you to turn on this Q3 transistor, which then essentially supplies the proper voltage to the relay to allow the heating element to turn on. There's a voltage regulator, some other resistors and caps along that DC section here. And that all connects up to the top where the timer control is. There's only 3 wires, so I believe 2 of the wires are basically just supplying power to the top board where the controls are to power it and give it, allow the timer to work. And there's just 1 wire coming back down that interfaces with Q3, which I believe is just there to turn on and off the relay. So that's essentially what I think is happening in the circuit. And I'll just go through a few pictures now. I'm showing you pictures of the bottom of the board and the top of the board, and you can kind of trace some of the paths there and try to reverse engineer it as well. But that's basically what I came up with. But I didn't really help me understand exactly what else is going on here, and why it exactly blew that cap. But I don't think it's just the cap. There's something else going on, and the cap must have gotten the brunt of the attack from at least what we know blew. But it probably took out other components. If the cap didn't blow first, then something else did, and then the cap showed physical signs of damage that way.
All right, folks, I managed to remove the bad cap here. Now, I don't know necessarily from this which end is positive and negative. I have the can right here, but remember, it blew off the top. And I did get it off with the zener intact, as you can see there. The zener is still there. The black end is towards negative, but this is on the positive side of the circuit, you see? From here, it goes through there and over here. So I'm assuming then that I'm going to install my new cap, which I have here. Same thing, 470 microfarad, 35 volts. Basically matching this one. I'm going to install it with the positive on this end and the negative on this end, because that zener, I think, was going the opposite direction for voltage control. So I'm going to put this in and see what happens. Hopefully it'll work, but I'm not really sure because there could be something else fried along the circuit here. But I figured let's give it a shot and see what happens. All right, well, it happens that if you look at the other side of the board with the cap removed, you'll see a plus side. So it's already marked, obviously, with plus there. And we have our zener with the negative terminal to the plus side. So it's reverse biased. And but I'm wondering if that zener is toast. I'm a little bit concerned that there's more stuff on this board that is bad, but let's see what happens. Okay, so as you can see here, I've placed the new capacitor, replacing this one here. Okay, there it is, about the same size. And my leads are in here. Looks about right, a little bit off, but I'll have to cut these leads in a minute, and we'll go ahead and see if this thing turns on. All right, the moment of truth. I've just plugged it in and I haven't turned anything on. Nothing's smoking yet, but I did hook up the controls to this thing. So let's see what happens. Hold on. Nothing. Nope. Yeah, so it's not just that cap. There's more stuff that's broken on this thing, and it is not turning on. So I'm going to be done with this thing for now. I don't think I want to waste any more time trying to fix it, because there's probably more components that are bad on the board, and I'm not going to go start trying to replace every one of them. It's just not worth it. But yeah, it is done. I'll see if I can troubleshoot it some more, but if you have any ideas, let me know. They're built for obsolescence, it looks like.
especially this brand. Wouldn't trust it as far as I could throw it.
And exactly that's what's going to happen with this. Sadly, it's going to end up in the garbage dump. I will chop it up as much as I can to maybe recycle it. But yeah, sadly, these things are not meant to last. And that's just more landfill, unfortunately, or hopefully recycling. All right, folks, so this is the unit getting ready for recycling. 2 halves. This metal inner lining, basically I just squashed it flat. Once the ends were removed, it collapsed very easily. You can see the handle and the lid, and there's the top and bottom parts that we're sandwiching on each side of this metal tub, and all the electronics, which is right here, and the handle for the lid. So I think I could pretty much get all the plastic components into the recycling. I don't think they'll take this metal part, but we'll try. And hopefully at least some of it will come to some good use after it's shredded up and recycled. But I don't know. Otherwise, not a very good longevity for this product, unfortunately. Not to mention the cost. Now, I got it as a present, so we never actually were in the market for a towel warmer in any case. It was gifted, and so we had no receipt, nothing to, even to bring it to warranty. We didn't know where it came from, what store it came from. Might have tried going to a store and seeing if they'll honor it and pretend that we've lost the receipt, but whatever. It would end up in the trash anyway, because they wouldn't repair it. They'll just send it back. And we might get a new one, but then we'll just have another one lasting for a few years and dying anyway. So I think that the end of towel warmers for us. We had a free gifted one, but not really something we're in the market for. And honestly, not sure if I'll ever even think of getting one again. Let me know what you think, if any of you have considered a towel warmer in the past. Thanks for watching. Catch you next time.